Hey, 12th graders. So we are wrapping up this unit. So this is our second unit that we've been talking about derivatives. So we're just kind of settling in with the idea of calculus and what exactly calculus is before we step it up a notch and talk about the second half of calculus, which is integrals. So the point that we're getting at right now is that we are bringing in everything that we've learned from the past 2 years, and now we're getting to this like intense problem solving ability. Can you be given really hard questions and can you problem solve through it? The hardest part about that is a level of grit. You have to be okay with not knowing. It's okay to not know, but taking a step back, stepping away from your desk if you can, or at least like when you're sitting in a desk during a testing time, like sit back, get a drink of water, and pause for a second and think about like, what am I missing? Where am I stuck? Why am I stuck? And how can I unstick myself? Is going to be some really big strategies that you can use. So, what I would encourage you to do is, I'm going to allow for every single part of the rest of these notes for you to pause the video and say, like, hey, try to go as far as you can in this problem without my help. Because I can sit here and explain it to you all day long, and hopefully it makes sense by the end of the problem, but that's because I'm making it make sense. It's my job to make it make sense. So now I want to encourage you to challenge yourself of, can I make it make sense for myself, and see where you get stuck, why you get stuck, and some strategies hopefully that can help you when you get stuck and you're completely on your own in the future. So we have three big problems, and they're all challenging in their own different ways. But we are still going to be following this like set of rules that we talk to ourselves. Like, can we represent it visually? What am I trying to optimize? Can I create a formula for that? Do I only have one input for that formula? And then how do I optimize calculus? And then interpret your answer. So all of these steps I think are important to keep next to you while we're going through these problems, especially when you're doing it on your own without my help, to then be able to further emphasize your problem solving process. Okay, first problem. To manufacture video game consoles requires the following costs per day in US dollars. In a factory capable of producing up to 100 units per day, 100 or sorry, $1,580 of a fixed cost, $120 per console for production cost. So hopefully we can take a step back here and be like, okay, so a fixed cost is like when I go into a taxi and they automatically set that like 250 euro up on the little window or on the mirror thing, which means it's like a fixed cost. No matter what, you got into the taxi, this is how much it costs, period. That's the idea of a fixed cost here. Of like, okay, it just starts off with costing that much. And then every time you purchase or produce a new console, it's $120 per that. So we can kind of understand like, okay, this might be a linear equation, but I don't know exactly what that's for. But you could write out even to the side of like, okay, 1580 plus 120 per multiplication 120x. Okay. And then it says Equipment maintenance costs vary directly with the square of the number of consoles produced. I want you to go ahead and take a look at all of these questions, pause the video, take a look at all of these questions, and see how far you can get. Yeah. Okay, so when I first went through this problem, I had a lot of confusion around costs. I was like, well, this is a linear representation of costs. And then this equation right here, or this sentence right here, is talking about varying directly with the square of cost. And then it's saying, like, hey, equipment maintenance, and then find an expression for cost. And it's just like a bunch of things talking about cost. And I was very confused about like what I was actually focusing on. And so what I found out as I was kind of like digging through, like rereading, looking through the further problems of like the total costs, right? Like that was a hint to me of like, oh, okay, so there's multiple costs. And so then I went back through and I reread, but it wasn't until I read part B where I was like, oh, there are multiple costs that are going on here. So if you want to pause now, you can, or if you want to stick with me, you can. But this is like a further hint of like, hey, there's multiple different costs going on here. So if you're still with me, we can see here that the production cost is this guy, right? In a factory capable of producing this, we have a fixed cost and then 4 production costs. So this is our production cost. Okay, so this is how much it just costs to make something. And then it says here a maintenance cost. So this is a different cost. Well, it makes sense that in order to like maintain the factory, you have certain costs that go hand in hand with that. And it says that this maintenance cost varies directly with the square of the number of consoles produced. This is something that we learned about when we were talking about models. So just be aware of that, that this is something we talked about a long time ago. And if you don't remember that, then you should definitely go back through your old notes and try and find where we talked about modeling situations. Varying directly means that y equals kx. Varying directly. So that was kind of our blanket formula for varying directly. But it doesn't say varying directly, it says varying directly with the square of. So y, maintenance costs, varies directly with the square of the number of consoles. Y equals kx, and then the number of consoles is squared. Okay, so if we don't remember how to do that, we can maybe reference back to our modeling unit and remember about direct versus indirect variation. So when it says, okay, given that equipment maintenance costs, okay, so we're talking about this guy, are $11 to produce 10 consoles, find an expression for equipment maintenance costs in terms of the number of consoles produced. So we need to find an equation or find an expression that represents this. And hopefully this was a clue of like, oh, this is a point that I can put in here, right? 11 is the cost, 10 is the consoles. So that's like, hey, 11 equals Y, 10 equals X. And what we're really trying to solve for here is K, because remember that K is a constant. It needs to be a number in this expression in order for us to have an actual expression that represents this. So if we go ahead and put these numbers in, 11 equals K times 10 squared, just plugging in 11 for Y, 10 for X, we end up dividing both sides by 100, which is 0.11 equals K. So we solved for K, and we can put that back into the equation of, okay, well, Y equals 0.11x squared. And that is the maintenance cost in terms of production of consoles, right? So again, breaking up, like what are the different costs? This is the maintenance cost. And then here it says, find an expression for the total costs. Okay, well, the cost total would equal to the cost of the maintenance plus the cost for the production, right? So that was my original clue, like, hey, there's multiple costs going on here. And we know that in order to represent all of those costs summed together would be an addition between the two. And so bringing that all back in, we're saying, okay, well, we have production or maintenance cost, which is 0.11 x squared. And then when I was up here, I had a little spidey sense tingling in the back of my brain saying, hey, that's an equation of a line. I should make an equation of a line up here. And I'm so glad that I did, because now referencing back, being like, oh, that was the production cost. So now I can add this expression in with my total cost. Just because I like to have order and reason to things, I'm going to put 120x plus 1580. But it's the same thing, right? I just want to have x squared x and then constant. All right, so I'm going to write it the way that they want me to, calling it C of x. And that is our total cost, the maintenance cost plus the production cost for every console. No matter how many consoles you produce, this is the amount that it costs, bringing in all the different elements that go into the cost of producing something. It makes sense, hopefully, while I'm talking about it, but it was hard. This one took me a while to figure out of like, oh, there's multiple costs. Got it. And then when it kind of finally like came together, then each question moving forward made a lot more sense.